for our next session, titled Space Observation in the Age of AI. Please welcome Will Marshall, co-founder and CEO of Planet Labs, for a fireside chat with Jeanne Meserve, host of SCSP's NatSecTech podcast.
Back again, with water this time. Will, hello. Nice to see you.
Great to see you, Jeanne.
So Planet Labs is the largest constellation, or has the largest constellation of observation satellites in the world. Among its clients is Ukraine, and it's been called a living testbed of innovation. Will, what services exactly have you been providing to Ukraine that you can talk about?
Absolutely. Well, look, with Ukraine, we are imaging all of Russia, all of Belarus, all of Ukraine every day. It's over 18 million square kilometers, so twice the area of the United States, roughly. So it's a huge area. And then using AI on top of that to find threats. They do things like building damage assessment, plan strategic strikes. They do threat assessments. It's really early warning, not just of what's going on in military installations in Russia, but also industrial activity and supply chains that might lead to that, trying to get the warning time not from hours or days, but maybe to weeks or months, so that they can plan accordingly. This information advantage has been critical to the balance of power. Drones, satellites, and AI have really been critical in Ukraine, and we've been proud to help support them.
Well, we've heard a lot about drone innovation in Ukraine. Talk to me, if you would, about satellite innovation. What have you learned? What have you implemented there?
Well, absolutely. As I was just saying, it enables the peripheral vision. Drones can't cover all of Russia for multiple reasons. Firstly, it would take millions of them to do that on a daily basis to give you that peripheral vision. But secondly, they don't have ability to go there with air because they don't have air superiority. Another way of thinking about it is actually, where do you fly those drones? Where do you send them? You should send them to places where you know there's threats. Actually, in Ukraine, they quickly learned that when they were using ISR drones, so drones with cameras, they were sending them up to the front lines, but 1 in 2 of those drones weren't coming back. Instead, now they just look in our imagery, and if there's no changes from yesterday to today, then they don't need to send the drone. So it's a smarter direction, so it's the tipping system for drones. They all rely, so the foundation of that in Ukraine has been satellite imagery that then tasks all of the higher resolution and other uses of drones.
So they learn a lot from your satellites, but what I'm wondering is what you have learned from deploying them this way in Ukraine. And have you given your satellites new capabilities, perhaps, that they didn't have previously?
We have learned a tremendous amount. As you said, it's an incubation, a testbed, and necessity is the mother of invention, and Ukraine has been deftly leveraging these new tools, all of them together. And I would say what we have been learning is speed really matters, so latency on getting these answers is really important. The peripheral vision is really important. And the only way we can tap the peripheral vision, that scan of all of Russia every day, is if you have AI on top of that. So leveraging AI is critical to doing the kind of analysis that you need at speed and at scale.
What would you say are the biggest opportunities and the biggest barriers when it comes to more deeply integrating commercial systems with military operations?
Well, it's a great question. I mean, let me give you a couple of examples of how we already are. I mean, we're just given Ukraine, but we also work, for example, with the US Navy, and they're monitoring all of the South China Sea. Imagine you're an analyst in the Pacific trying to monitor all the whole of the South China Sea. It's too big, right? So we help them by imaging all 13 million square kilometers, automatically finding ships. They can set thresholds for, tell me if there's this kind of activity, tell me if there's ship bunkering, for example, when ships get together and do some illicit activity. Tell me, alert me across this vast area if those sort of challenges. So we can do things like that. We work with NATO on doing similar things to what we provided for Ukraine, but in the Baltic Sea and across the whole eastern flank of NATO. But there's so much more. So that's the sort of defense application. But in the intelligence world, we've seen Ukraine innovate there. The US, you'll be surprised to hear, actually hasn't leveraged this data yet. The US intelligence community uses, you'll be surprised to hear, less than 1% of our data today. So they're leaving lots of...
Why?
Well, because their geospatial process is dependent on a few analysts. And if you just use analysts, they were used to dealing with thousands of images per day, but Planet alone has millions of images every day. So it's about 1,000 times more data than they were used to. They couldn't deal with it through analysts. You've got to use AI, and what it can do is not replace the analysts, it can empower them so that they can cover a much greater area. But they haven't done this shift. It's a cultural shift, it's a change in mindset. Also, frankly, the requirements process is broken, right? So what happens is they don't even know they can ask for this capability, and they're dealing on the process for procurement is slow and very specialized, and this capability is fast and very general, and so it doesn't match together. We've got to have new kinds of funds that are fast and flexible. They don't need to be vast. They don't need to be in the billions and billions. They actually can be relatively small. They can be tens or hundreds of millions, but they need to be able to change. When there's a new AI technique, they apply it. And I would call it moving from a sort of requirements-driven process to a more capabilities-driven process. That's what we do in Silicon Valley. We look out at the principal needs of users, not just what they're asking for. Oh, a slightly better computer like this. We think, what might they want to do? What's the power if we could do everything, if we could answer all these things? That's what the AI companies and the other tech companies around here are doing. If you take that lens and you go, what are the principal needs of the IC and the DoD? Well, it's to find all the threats around the world and give you real-time information about that. There's no specific requirement for that, because no specific person in some specific place has asked for that. But yet it's empowering across. So the procurement system is broken, and they don't have a direct need. But I would say adapting to leverage this tool is no longer just an efficiency matter. It's faster and more efficient. We've seen in Ukraine how important it is. It is an existential thing if your adversary is using that and you are not.
So you've talked about Ukraine using it, the US isn't. I'm sure you work with a lot of other governments. Is the US the exception to the rule?
Let me be clear. The US government is using it, the NRO is using it, the NGA is using it, but they're only really using the tasking system that we have, not this scan. And so the benefit of that scan and I think we need to change that, and we need to go faster to adopt this technology. And I think this administration is leaning in to adopting commercial technology and breaking some of those barriers that have existed that are getting in the way to help leverage this sort of new technology.
So apart from slow acquisition and funding and perhaps not a full appreciation of what AI can do, are there other limits to the private-public partnership model?
Not many, I don't think. I think there's cultural differences and speed and so on, but not really. I think that we're seeing companies like Planet are proud to work with the government, and we want to try to support them. And I think the government can so benefit from these sorts of technologies.
So you are embarking on a moonshot project, excuse the pun, with Google called Project Suncatcher. What is this?
Yeah, this is a fun one. So it's really quite an amazing project. So Google and others have been looking to see where can they expand compute. They just can't go build compute fast enough. And Planet and Google are working together on a joint mission to see if it's possible to put data centers into space. Now, that might seem crazy and far out, but as launch costs come down and satellite costs come down, it's only a matter of time where the benefits of space, which include 8 times more solar power per panel, and so continuous power and continuous cooling, and plenty of space, no issues of land and so on, can both be more efficient and eventually more sustainable as well, because we don't need that land and continuous resources. I mean, space geeks have been thinking about this for decades. We talk about the fact that we can take energy-intensive infrastructure from Earth, like compute, like power, into space and then get the benefits just beamed down. But finally, it's not crazy to think about that as launch costs and satellite costs are coming down. And so we are starting and embarking on this. Yeah, it is very experimental at this stage. It's early days, but if it proves feasible technically, it's an incredibly big opportunity. And it sounds in the realm of science fiction, but it's becoming in the realm of science fact. And we're putting up a first demo next year with Google. We're very proud that Google selected us, and it's because we've launched hundreds of satellites before, done that sort of scale. We've worked already with them a lot on AI, and so it was a natural. But we were very proud that they selected us for this moonshot project. It's exciting times.
So there have to be technological challenges in doing this. One might be the environment. It's tough out there in space. Are you sure that the equipment that's needed for a data center is going to be able to survive and operate?
Well, that's exactly some of the things we're testing in the first missions. So one of the toughest things is the thermal environment. It's how to get rid of the heat that you generate. On the ground, we would use water cooling. Obviously, we're not going to do that in space. We have free cooling to the cold background of space, but it's radiative cooling, so you have to build lots of radiators, and then there's upsets from radiation that could happen. And again, so these are all the reasons we're putting a few TPUs, the Google's advanced graphics processing systems, into space, and seeing how that works and learning these lessons, so we can decide how what it would take to scale a project like that.
Reading about this involves more than one satellite. I'm wondering about the communication between satellites and if that is a challenge as well.
Not too big. Google envisions clusters of spacecraft. They published a paper on this that would be quite close together. It would be optical links between them. All of that sort of thing has been solved. There's no fundamental things standing in the way. It is a big engineering challenge, and we're very excited to be working on it.
What about the proximity? If you've got a number of satellites in close together operating these systems, are there hazards potentially there?
Yeah, I mean, you have to do formation flying, which is a real technical issue, but there's nothing that we haven't solved before in doing that. It's just the numbers of satellites that you have to keep proximate, flying next to one another in proximity. But there's no outstanding fundamentals to doing that. We have to fly it low to make sure it doesn't create long-term orbital space debris, just like other big constellations. This one uniquely was flying a sun-synchronous dawn-dusk orbit, so that the solar panels always face the sun. That's one of the amazing things we can do in a dawn-dusk sun-sync orbit. So we're thinking about all the challenges of that, and it's exciting.
Is space junk a potential hazard?
Space junk is a potential hazard today to spacecraft, and we do collision avoidance with many community of space actors. We regularly talk to one another and resolve that. We keep planning our satellites really low, so it's in that self-cleaning area of orbit that even if something goes wrong and the satellite goes out of control, say, it would just come down automatically. And by the way, we've maintained a 100% success record of contacting our satellites. We just launched another 38 last week and connected with them all. And so we rarely have that challenge. But if it were to happen, these satellites come down in a very short time. Actually, they're designed to come down in like a month.
So you mentioned the launch timeline. What's the longer timeline, presuming launch is successful and your experimentation also works out? Do you have a timeline?
Well, you mean for the Suncatcher project?
Yep.
With Google? We'll reveal more as it becomes the right time. But I mean, the first stage is, let's see if those TPUs work in space. Let's overcome some of those thermal challenges and other things. And we're excited to scale quickly thereafter, but I haven't got any specifics to share.
Let's talk about AI and its integration into satellites and how this has changed the game. Talk to us about that.
Yeah, I mean, so we're seeing, firstly, we're putting a lot of effort into AI processing once the imagery comes down to the ground. That's all the things I was just talking about, how we work with Ukraine, NATO, and so on. But another challenge is, do we want to put compute at the edge so that we can process all the imagery upstairs? And so now, in the last few missions, including the one we launched last week, we put the NVIDIA GPU, NVIDIA Jetson Orin platform in space. It's the fastest processor in space that we're aware of, at least. And that enables us to process AI at the edge. That means instead of sending down those millions of images of the South China Sea for that analyst that we were just talking about earlier, we could actually just send him or her the latitudes and longitudes of all the boats because we've already done that AI upstairs. Actually, and the advantage of that is that it can get there back to them within seconds rather than waiting to download all that data and then process all of that data en masse. You just do it at the edge. So there's actually a convergence between that, what we were just talking about then, and the Suncatcher project. Because I think we're going to move towards, I think in the long run, so there's exciting applications of AI at scale on Earth imagery today. But in time, we're not just going to have a queryable Earth where you can search for objects around the Earth. I think we're going to move towards a system of planetary intelligence. And that is where you combine compute and sensing and comms in one. So those things are going to merge. And you'll note that biology did this very smartly. It put the eyes next to the brain so that we can process the data really fast. All the sensor systems, actually, that's why the brain evolved near the mouth. We have sensors, the brain processes it all really fast. And that needs a much smarter way of having. And that leads to an integrated intelligence where sensing and compute are right there together. We're going to be doing the same. More and more compute right next to all the eyes of our satellites such that they can have more combined intelligence. And I think, so again, back to the thing I was saying before about the LLMs, they have very limited data right now. The LLMs, ChatGPT, Gemini, Claude, they are mainly trained on the text of the internet. It's about a 9 terabyte mass of data. But we are collecting 30 terabytes of data every day, and over time have collected 50 or 100 petabytes of data. It's orders of magnitude more data. And to process and keep that all in is going to need a lot of upgrade, but it's going to have incredible power to do very different things. That's how human consciousness helped to evolve. So by bringing in this data, we'll bring in, let's say, more awareness so that AI is not just answering about text of the internet. It's being able to answer questions about the physical planet. And that's a wholly different domain than what AI can do today. Real-world models is the direction. In fact, all the leaders of the AI labs are talking about building real-world models. Well, for real-world models, you need real-world data. But then, if you can do that, and integrate all that data. The power is that, again, you can answer questions, not just of the text of the internet. You can answer questions about anything on Earth in real time, and in a semantic way, and just like you do with ChatGPT. And that is just incredible. Imagine being able to answer any questions of the planet. That's where we're going. I think it's a sort of planetary intelligence, and that's the amazing upshot of the revolution, the simultaneous revolutions that are happening in space, more satellites and cheaper satellites and rockets, and AI, these incredible large language models and the power of that. You combine that. That's why I really think that Planet is in a unique position, because we do this daily scans, the most relevant data set to AI from space. I see a merger of those two things. Planet, we see ourselves at the intersection between those two revolutions, the space revolution and the AI revolution. And I think the upshot is going to be incredibly powerful.
I hate to bring you from that big picture down to something much smaller, but going back to computing on the edge, I presume one of the huge advantages of this is reducing latency, right?
Yep.
Getting information faster, which is needed certainly in a situation like Ukraine.
Yep, or disaster response or many other applications. But yes, quick data is critical to a number of applications.
You know, Ukraine's a war, duh, but I'm wondering if you have a vision of your technology being used someday for peace.
Absolutely. Well, I sincerely believe it already is, including in helping Ukraine bring peace there. And But beyond that, we've seen in and around Ukraine myriad NGOs, from Human Rights Watch monitoring war crimes to NGO like media, shedding light for everyone to see what's going on, to think tanks doing analysis, to the World Food Programme looking at our data to understand the food supply, because Ukraine was the breadbasket supplying half the grain to the world's poorest countries through that program, and that suddenly was being restricted. So where was that grain going? How does it? And then it led to investigative journalists figuring out which ships were going where, under which ones that were in keeping with the sanctions and which ones weren't, and so on. And so I think of this as part of a broader process of transparency that brings accountability to warfare, that is critically important, not just to help open societies, firstly, that's critical, and I think open data like ours, it's unclassified, enables that sort of accountability the best, because people can check each other's maths, but also it is important because it's a deterrent. Because if everyone knows, I mean, if you look back at the history of war, most wars started with a mistake of some kind, or someone assuming someone had this capability when they didn't, or had this troops there, or what have you. Mistakes lead to war. The more information is power, having more players, including civil society, understanding all these capabilities, will then, I believe, bring more accountability, which then drives peace and security. So in a direct way, and in that sort of theory of change in the broader sense, and that's why we call our satellites doves. We really believe that on a peaceful mission, including in helping in the national security domain.
However, to push back just a little bit, in the case of Ukraine, there was satellite imagery that showed that the Russians were preparing for war. Didn't stop a thing.
Right, correct. And I think one of the differences today from then is that Putin, I think, genuinely didn't know that this capability exists, or wasn't aware of the ramifications. And I think today, if you did the same, would other countries make similar ventures now knowing that the rest of the world is going to find out in real time what's going on, and they can't hide things like mass graves or invasions or what have you? I think it may change the calculus. Look, I'm not saying it's a silver bullet to solve all world peace, but I am saying that I think that it can play an important role in transparency and accountability, which is an important side car to peace efforts.
And it could be predictive as well, to some degree, correct?
100%. 100%. Looking back in our data, it was now clear that the Russian exercises in the summer before, many months before they invaded, were very different. So can we do the same to prevent? And if you have that time, you can do more with diplomacy. You can do. Now, we didn't know that at the time. We didn't look in our data for that at that time. But looking back after the invasion, we could say, oh, many months earlier they were doing this. It was very different than the prior years. Maybe they're preparing, and that's the opportunity to prevent the war in the first place, right?
We have a lot of people representing industry here in the room, and I'm just wondering what breakthroughs you see coming along that could transform how government and commercial entities interact in this sphere.
Well, I think AI is the foundation of the biggest change, and what that does is the upshot is three things. One is, as I said, it empowers those analysts to do much more. The second is it democratizes that, so that it's not just the PhD in geospatial intelligence that can actually get access to this. And thirdly, it brings along civil society in that same thing. Think tanks and NGOs and news media can access some of that, perhaps with a delay, but they can access that and hold accountability to those efforts. And so I think it's game-changing. And what I think is exciting from an industry standpoint is that we're at the beginning of opening up a huge market here. This isn't a few billion-dollar market. It's tens, if not $100 billion kind of market. That's our estimate, sort of $75 or $100 billion market. And it's highly aligned with us driving greater peace through coordinated understanding of what's going on, as we've seen the role of open source intelligence. It's one of the key ingredients that enables us to triangulate truth. And I think it also is just an incredibly beautiful thing for us all to know about how the planet is doing and all the sustainability and other benefits at the same time. So I think it's really important for both security and sustainability.
Will, you're a big thinker here. You are endlessly creative. Give us a few words of inspiration to wrap this up. I mean, the whole thing's been inspirational.
Just inspirational.
But you take it to the next level for me, Will.
Well, let me just end on the point about AI today is like brains with no sensors. You know, would any of you want to be a brain with no sensor? I mean, they've been fed some facts, but they've not had sensors, really. But imagine bringing sensors to AI, that is AI with a brain and eyes. Then you can imagine us building, and the natural eyes for AI are satellites, because AI wants to see the full picture. And so that combination of AI and that data is where I think we'll see the emergence of planetary scale intelligence. And I think that's an incredible vision that we should aspire to build towards.
Okay. Will Marshall, co-founder and CEO of Planet Labs, always an inspiration to talk to you. Thanks so much.
Lovely to chat, Jeanne. Bye.